let's be real. AI systems are pretty much the most valuable assets on the planet right now. But with all that incredible power comes an equally incredible vulnerability. So today, we're going to dive into what's called the AI encryption shield, a full-on strategy to protect these digital crown jewels from the inside out.
So what's the one weak spot in these super complex, brilliant systems? What's the Achilles heel? I'll give you a hint. It's not the fancy algorithms, and it's not the powerful hardware. No, the single biggest point of failure is something way more fundamental.
Yep, it's the data. The training sets, the model weights, the prompts from users, all of it. An AI is absolutely nothing without its data, and that data is vulnerable in 3 different states. Let's break down what that actually means. And if that data gets exposed, we're not talking about a small problem. It's catastrophic. Think about it. Attackers could steal your entire model, the very brain you've spent a fortune building. Or they could poison your training data, making your AI completely unreliable. Or worse, they could just pull sensitive user info right out of the system. The stakes just couldn't be any higher. Okay, first up, securing data in motion. The best way to think about this is like protecting the entire nervous system of your AI. It's all the information that's constantly flying back and forth between all the different parts.
So what is data in transit? Well, it's pretty much any data that's on the move. We're talking user prompts hitting an API, training data getting pulled from a database, or even different AI components talking to each other. It's this constant, super fast flow of information, and a lot of it can be really sensitive. And for every risk, there's a protection. So for data that's moving across the big open internet, you've got threats like man-in-the-middle attacks. Strong TLS 1.3 encryption is basically the shield for that. But what about all the chatter happening inside your own network? That's where something called mutual TLS, or MTLS, is an absolute game changer. It creates this private, secure tunnel where every single service has to prove its identity before it's allowed to talk. No imposters allowed.
Okay, so we've secured all the data while it's zipping around. But what about when it's just sitting there? That brings us to our second front, protecting data at rest. You can think of this as putting Fort Knox-level security on the digital vault where your AI's most valuable secrets are stored. Data at rest is, your stored data. This is the digital gold. This is the big stuff like your massive training data sets and those priceless model weight files that basically are your secret sauce. It even includes things like vector embeddings, which are kind of like the AI's internal map of how ideas connect. If those get stolen, an attacker can learn a ton about your original data. This is the stuff they're really after. So the defenses here are all about layers. To stop someone from just walking off with your model, everything gets encrypted with a super strong standard, like AES 256. To protect all that training data, the vector databases themselves have to be encrypted. But what protects the keys that do all the encrypting? That's where hardware security modules, or HSMs, come in. An HSM is like a tiny physical fortress built just to protect your keys, making them almost impossible for anyone to steal. And now we've come to the final, and you could argue, the most critical piece of this whole puzzle, protecting data while it's actively being worked on. This is, without a doubt, the last frontier of AI security. So, data in use is any data that's been loaded into the computer's memory, like its RAM or the GPU's memory, so it can be processed. Now here's the catch. For a computer to actually use data, it usually has to decrypt it first. This creates this tiny, fleeting moment where the data exists in plain text, completely exposed in memory. And that's exactly why this is so critical. Don't just take my word for it. The source material is crystal clear on this one. It says this is the most overlooked and most dangerous state in AI systems. It's that one moment of maximum vulnerability when all your secrets are just laid bare right inside the machine's memory. So how in the world do you protect data that has to be unencrypted for you to use it? Well, the solution is this incredible technology called confidential computing. It uses something called secure enclaves. Just imagine a sealed, tamper-proof vault that's built right into the computer chip itself. Data goes into this vault encrypted, it gets processed inside the vault while it's still encrypted, and only the results come out. Nobody, not even the cloud provider that owns the server, can peek inside. This just slams the door shut on memory scraping and other really sneaky attacks. So we've covered all 3 states: data in transit, at rest, and in use. But here's the key takeaway. These are not separate options you can pick and choose from. They have to work together as one single, seamless strategy, a unified shield. This table really pulls it all together. You can see exactly how each layer of the shield handles a specific type of risk. Your in-transit protection is your guard against anyone messing with your data while it's on the move. Your at-rest protection is your vault to stop theft. And your in-use protection is that final, crucial defense against memory exposure. You need all three. It's that simple. And this, right here, is the bottom line. It's not a buffet. You can't just pick the security you feel like having today. Leaving even one of these states unprotected is like locking two of your three front doors. A determined attacker is going to find that one unlocked door. Comprehensive encryption is an all-or-nothing game. So we'll leave you with this one question. We know your AI is powerful, but is it actually truly protected? After walking through all this, can you honestly say your system is secure across all three of those data states? Because in the world of AI, real power isn't just about what your model can do. It's about how well you can protect it.